Welcome back, physicists, and today I want to just briefly go over this reading about vectors, scalars, and trig, and then show you some of the trig practice problems and using calculators to solve. So to review, or to maybe teach, in physics we have quantities called vectors and then quantities called scalars. And the difference between a vector and a scalar is that a scalar is just a number. It doesn't have a direction, so something like time. There's only one way time can go. If I tell you 5 seconds have passed, it can't be going backwards. And mass is the same way, and speed happens to be the same way. You can remember that scalar means that because scalar and speed start with the same letter. Vectors, like velocity, have a direction. So they have an arrow that points to the way they go. Vector to velocity, scalar to speed. Vectors can go just in the x direction or just in the y direction, but a lot of the times they go in between. So we can see this vector A is partially on the x-axis and partially on the y-axis. And if we want to solve problems with forces, we're going to need to figure out the two components, the two sides of the triangle that make the vector A. So using trigonometry, you probably remember adjacent, opposite, and hypotenuse. Remember, hypotenuse is always the longest side. It's the one across from the right angle. And we'll use sines, cosines, and tangents. And if we're looking for the angle, we'd use inverse sine, inverse cosine, and inverse tangent. Remember that these don't mean 1 over. It's not a -1 like a regular exponent. It's a specific function, the inverse sine versus the sine function. Okay. So the problems that I'm going to assign to you will just be the odd numbered problems. If you want additional practice, you're more than welcome to also do the even numbered problems. Just for extra practice. If you're really struggling with the odd numbered problems, maybe do the even ones so you can get good at it. Okay, let's look at this. On this, we have an angle for 1. We have the adjacent to that angle, and we want to know the opposite. So writing down SOHCAHTOA at the top of your paper might be really helpful. And if we have adjacent and opposite and an angle, we're going to use tangent. So tangent theta equals opposite over adjacent. I want to solve for opposite, so I'm going to multiply both sides by adjacent. Now I can plug in my numbers. 12 meters times the tangent of 35 degrees. I need my unit for degrees in there as well as my unit for distance. It's going to be the height of the opposite, the height of the flagpole. And I can plug that in a calculator. I'll put 35 in, calculate the tangent. Oh, put 12 in, and then times the tangent of 35. And I get 8.4. Let's look and make sure that makes sense. Okay, it's not the hypotenuse, so it doesn't need to be longer. So the opposite being 8.4 makes sense. And it should be meters. Awesome. Great, now let's look at problem 3. So we have a velocity here, and we want to know the velocity here. The plane is flying forward, or at least trying to, and the wind's pushing it to the side, so it's actually going to end up over here over time. And so we want to know the hypotenuse, we want to know the angle, and we have adjacent and opposite. So rewriting SOHCAHTOA, because I can't see the top of my screen anymore. I have adjacent and opposite. I want to find hypotenuse, and I want to find the angle. Let's start finding the hypotenuse. So I know Pythagorean theorem that a squared plus b squared equals c squared, where a can be still a, b is the opposite, and c is always going to be the hypotenuse. It's really important if you try and solve for it the other way. It's not going to work. This is always the longest side. It's always c. And you know that because it's opposite the right angle. So this should be pretty easy to solve. 65 meters per second, all squared, plus 16 meters per second, all squared, equals the hypotenuse squared, which means the hypotenuse will be the square root of whatever I get there. So let's grab that calculator. 65, gotta clear that. 65 squared plus 16 squared. Okay, that gives me 4,418. I'll write that down. That will be meters squared per second squared because the square goes on the units as well as the numbers. So the hypotenuse will be the square root of that. Oh, that was 81, not 18. Good to know. Okay, 66.9. And this is 18 turning into 81. Okay, and for the units, if I square root meters squared, I get meters. If I square root seconds squared, I get seconds. And that makes sense. I want my velocity to be with units of velocity. And for the angle, now that I know all of these numbers, I could use SOHCA or TOA, but I'm going to stick with TOA, tangent, in case I made a mistake there. That way my mistake doesn't carry over. So I have tangent theta equals opposite over adjacent. I want to solve for theta, so I'm going to rewrite it with an inverse tangent. And then I'll plug in my numbers. Tan -1, opposite is 16 meters per second, adjacent is 65 meters per second. Be very careful about which one you put on top. If you put the wrong one on, you're going to get the wrong angle, and you'd get this angle over here. The units will end up canceling out. What you put in the inverse tangent function should be dimensionless, and it will give you out degrees. So we want to do 16 divided by 65 tan inverse. Let's see how I can do that on here. There we go. So clear, tan inverse 16 divided by 65. Let's make sure that's what I want to put in. Yep. Okay, and I get 13.8. Down here, 13.8 degrees. Awesome. Great job. So let's briefly explain here. For this one, you have your right angle here, which means this is your hypotenuse. So you're going to use a squared plus b squared equals c squared to solve for the side which is c. For 7, you want to find an angle here. This would be opposite the angle, and this is the hypotenuse because it's opposite the right angle. And so you would use sine. Awesome. Ooh, 9 looks tricky. For this one, you have 134 centimeters and 1 meter. So make sure you can convert that to meters before you proceed. Or you could convert this to centimeters. It's your choice. And we want to find the angle. Since this is adjacent and this one's hypotenuse, we would want to use cosine. Great. 11, you want to find the angle up here. If this is the angle, this one is opposite and this one is adjacent. We'll use tangent. For 13, this one's a little bit tricky because it's starting to talk about force vectors, and it says y is over here and x is over here. But you can see that, like, this line right here is equal to that line, and this line is equal to that line. So you can pick a triangle to use and use the same one, or you could solve with two different triangles and just know that the two sides here and here would be equal. It looks more complicated than it is. So I know this angle and I know the hypotenuse, and I want to find both the adjacent and the opposite. If you want to use this one over here, you would have to know that this is going to be 62 degrees. Is that right? Yeah, 62, because these two together would add to 90. Okay, all right, good luck with that.